Hi, it's Lester Martin from Hortonworks University, and we're continuing on in the Hadoop Essentials course, and this next module is titled Backup and Recovery. And what we're going to focus on here is understanding where backup and recovery makes sense in a Hadoop cluster, given the fact that Hadoop itself has much redundancy and reliability functionality in place that's focused on ensuring no loss of data or loss of data only in extreme scenarios. So we're kind of focused on those extreme scenarios and why that might be a good thing, and then finish with a demonstration with the Apache Falcon doing some movement of data from one cluster to another. So again, we'll focus initially on some protection, and we might ask ourselves, if HDFS already does 3 copies of everything, what do we focus on here? Well, if it hasn't become clear, let me say it clearly. Hadoop is a data center centric technology, meaning we should run our our Hadoop cluster in a single data center. That's very critical for performance, just for the basic operations of a cluster. Will not do well spanning 2 data centers and beyond. So that's the main effort. So we really are talking about now, making copies of data, just in case we do have some big disaster, much like you see on the right-hand side, many things that could go wrong that are really, again, the whole data center or substantial elements within that data center. So this is what we're talking about, of storing data differently from Site 1 and Site 2 and those kinds of events. And again, that DR plan, that DR attack is very company specific, very enterprise oriented about what needs to happen when, how fast, etc. So we're trying to talk about functional tools, basic tools that can be leveraged for individuals and their organizations, their enterprises, to ensure they have an adequate disaster recovery plan. So if we start thinking about what we would back up in a modern Hadoop cluster, 100% for sure the things that come to mind are the actual data that sits on the file system, the data that surfaces your Hive tables, maybe your HBase environment, any of your analytics. So this information is critical. Now, I would say for sure we're talking about that raw representation of data as you first ingest it. If that's something you maintain, definitely we would want to make copies of that. But as we go past raw, we have to make some choices if we want to be cognizant of having a cost-effective second cluster to store this additional information to, and we want to be careful to not spend so much processing time and so much clock time on just making sure we have things replicated. So we may make choices about those finalized, aggregated, cleansed, etc. information. If we have the raw, we have the code, we should be able to reproduce. So you have to find that right combination of the two, of how far from only raw to everything you have in your system. Something to consider for sure. And as we look at a little deeper into what else you need to have, you definitely have to have what I would call the control information, or the metadata information that exists. For sure, name node, the metadata that makes up the file system, that's very critical. Some of this is to reproduce. The name node specifically is if I want to recover, and this is so disaster, but maybe still in that single data center. If we're moving data from one HDFS cluster to another, they'll have separate name node metadata, but very critical from restoring a single, back from backups to a single cluster, very critical stuff. And most of these control databases fit in that space. You'll probably come up with strategies where you deploy your code to 2 different data centers, if that makes the most sense for what you want. And those code deployments, those use of these tools will update most of this metadata. So this is really thinking about data center issues, and then you want to recover in that data center. And then lastly, kind of fitting with that, is there's a variety of config information. Now, we think of Embari as our controller, or our technical administrative tool to maintain this information. So definitely we'd see, as you saw there, kind of a circling here, the Embari control database is critical. A lot of people go just one step further and maybe even back up the underlying files that Embari itself creates. Again, you have to decide how far you take this backup, and then backup recovery, and then full-on disaster recovery type strategies. We're going to make sure you have some tools and some information to make good choices with that. This slide just points out some of the things to consider. I suggested quite a bit about maybe not pushing everything from data center 1 to data center 2, as long as you can reproduce and your SLA allows you to take that reproduction activity to occur, then you could get away with much less storage, much less network, of course, and then of course by having those smaller, your windows become easier to fit within, etc. Many things to consider as we talk about backing up for the purpose of restoring to a single data center and or recovering in a second data center for those full-on large gigantic disasters that we think about when we talk about DR. One strategy, one tool that HDFS, that Hadoop has, is a concept called snapshots, and this is a very powerful tool that actually is very lightweight and is very speedy. And simply, snapshots, what they're trying to do is keep a view of information from a folder, possibly very recursively driving through that folder, of what a particular folder, when we make a snapshot, contained at that given time. The good news is there's not a copy of information at that time. What we simply do is we create pointers back to the underlying blocks that surface those, that represent those files, and which makes it a very speedy operation. It's a metadata only operation. The things to consider with snapshotting is if you do delete the information that we made a snapshot of, then we actually are holding on, because we have kind of pointers back to those blocks, we're holding on to that information. So what it really means is if you create a process, manual or automated, to create snapshots, we do need to make sure we're also creating a process, a corresponding process to delete those snapshots. Otherwise, we'll eventually fill up our HDFS just by taking care of snapshots. So some good scenarios listed there in those final set of bullets. And this snapshot, this picture is trying to get a view of that. So we have a directory 2 that has a directory 3 with file A and file B, and it's really just trying to show that if we made a snapshot, we name snapshots. We say something like, hey, create a snapshot with a snapshot name and then a target directory. And in fact, there's a special folder called the .snapshot folder, which would then have a folder with your name that you gave the snapshot. And then actually when you do an LS, when you're walking the file system, it will look like and taste like there are real files there. In fact, they really are. There are files there that are referenceable, copyable, etc. But they all point back to the original file. So this file A and file B at this point in time actually are the exact same contents of the file A and file B that we see in directory 3. And what we're trying to show there is with these dotted lines is that they in fact all point to the exact same data block. There's no additional footprint that has to occur to make that happen. Under the covers, another strategy, another tool we have out there is called DiskCP. This is the movement of data from one cluster to another. Very foundational tool leveraged by many of the systems directly, and sometimes because they think about movement anyway at a little bit higher up in the ecosystem. But it's a baseline HDFS, and it's actually run as a map reduce job as well in Yarn. And as you suggest, it could do more than just from HDFS to HDFS, but that seems to be the use case that we see often leveraged. A combination of those snapshots with DiskCP are very powerful, because we can very quickly and finitely say, yes, right now the information that I see on disk right this very second is what I care about. So creating a snapshot that's near instantaneous in its response time, and then making a copy from those snapshot folders to a different cluster actually works out well. We don't have to waste any additional space on source cluster. We still have to move the data across the network to the destination cluster and still have to lay it down. So this model could work well, and then either right after that movement happened, actually delete a snapshot right there. Seems to be a good combination. Unless you are making that snapshot some other process, and then that you wanted to have a number of snapshots and then do periodic copies from there as well. So a great combination of putting these two tools together can be very effective to get your basic information out of HDFS from one cluster to another. So as I said, it was a quick module, nothing too deep, too heavy. Just want to give you some awareness and maybe some quick questions there. Would they, for sure, if HDFS already is maintaining multiple copies across nodes, across the worker nodes, etc. Why do we need this? We're really talking about here those large, those true catastrophes, those true disasters that in fact could take out an entire cluster. And you have to ask yourself, what's your operational model? Is that something you need to account for? And if so, you will have to move that information from one sender, one cluster to another. Good true-false question about this. Are snapshots fast because they move a minimal number of data copies, of data blocks are actually copied when that snapshot gets created? Well, it's kind of a trick question. Snapshots are fast, but not because of this reason. We simply do maintain additional pointers or redirections back to those original the original file to file you're snapshotting, original blocks itself. So that's what makes it fast. And then lastly, what two frameworks could we use to automate backups? Probably didn't say it as much here. I'll just kind of say it out loud. Is Oozie. Oozie could be used I'm sorry, DiskCP that we did mention a moment ago. I'm so sorry. DiskCP that moves things around. Now we can automate DiskCP with Oozie, the workflow system that we mentioned in an earlier module. Would be a great way to do that. And then in fact, Apache Falcon itself has some very pointed and directed use cases and scenarios and tools that we'll see in the demo in a second, really focused around streamlining and making this process very straightforward and very auditable, very visual to see when it was last time this operation occurred, etc. So quick summary, as I mentioned, these really just fit in with the questions and answers I just mentioned, as well as the previous slides. That second bullet, many things to consider, either and or for dealing with what if you want to recover from the original data center, and or you want to move, you want to pick up and move on into the secondary data center. Great points about snapshots, just point in time, not wasting additional data. As that last block says, very fast, all in the name node, etc. So it's the same information that gets written to the name node's edit log itself. And a great combination is snapshots plus DiskCP, and maybe driving that either with your own custom workflow with Oozie or using Apache Falcon, as we'll focus on in the demo. All right, appreciate your time and looking forward to the demo just next.